still, I think most people have stopped trickling in. I'm sure we'll have more people joining us in a minute, but I want to say welcome to everyone and get started here today. My name is Arthi Garg, and it is my absolute pleasure to welcome you to today's discussion, which is the second of a three-part series called Power and Indigeneity. This is a three-part discussion of the climate transition, energy, and Indigenous lands. And there's several of us organizations that are co-hosting this series of events. Myself, I am here representing engineers and scientists acting locally. We're a 501c3 nonprofit with the goal of getting more people with backgrounds in STEM engaged with their local governments and communities. And I will introduce folks from two of the other sponsoring organizations for this series in just a second, but first I wanted to just welcome everyone and also ask when folks introduce themselves to acknowledge where they're coming from. We're a virtual series, so we're coming from many different locations, and which peoples were inhabited on the land previously. So I'm coming to you from Hayward, California, and these are the ancestral lands of the Muwekma Ohlone tribe. With that, I'd like to hand it over to Kelsey to introduce the Institute for Tribal Environmental Professionals.
Thanks so much, Artie. Hi, everyone. My name is Kelsey Morales. I'm with the Institute for Tribal Environmental Professionals, ITEP, and I work with the Tribes and Climate Change team. And I'm joining you from the homelands of the Pueblo Ute and Dene peoples. So right around the Durango, Colorado area. And yeah, it's been such a pleasure working with ITEP and with all of these folks from GSA and ESOL for this webinar series. Just really briefly, ITEP was funded by the late Virgil Masayesfa and the former dean of Northern Arizona University, William Auberly. And it was in collaboration with the Environmental Protection Agency back in 1992. And so we've been around for about 30 years now, and we act as a catalyst between tribal government, research and technical resources, federal, state, and local governments, as well as the private sector to support tribal natural resources. And within ITEP, there are 8 different programs, everything from working on air quality to tribal waste and response, environmental education, and then, there's definitely more, and then the Tribes and Climate Change team. And so our program actually emerged in 2009. And in the early years of our formation, we focused on basic climate change education, and since have evolved to focus on supporting tribal climate change adaptation, mitigation, and resilience planning work. And we do this typically through webinars, workshops, and courses from 101 level to more advanced, as well as conferences. And we actually have an upcoming conference at the end of August, both in person and hybrid, in St. Paul, Minnesota. So thanks so much, everyone, for having me here, and excited to get to our panelists here soon. And I will go ahead and pass it off to Mark Little from GSA. Thank you.
Good afternoon, everyone. My name is Mark Gabriel Little, and I'm the president-elect of the Geological Society of America. I am in North Carolina, and today there are 8 tribes that call North Carolina home: the Coharie, the Eastern Band of Cherokee Indians, the Haudenosaunee, the Lumbee Tribe of North Carolina, the Meherrin, the Saponi, the Occaneechi Band of Saponi Nation, and the Waccamaw Siouan. The Catawba Nation, which is based in South Carolina, also reaches into North Carolina, as well as the Tuscarora tribe, which is currently not recognized. The Geological Society of America is a membership organization of nearly 20,000 geoscientists and earth science enthusiasts located on every continent, including Antarctica. Our mission is to advance geoscience research and discovery, service to society, and stewardship of the earth. And I'm very excited about the panel today. Very happy to be working with colleagues from ESAL and ITEP on putting all of this together. On June 15th, I had the pleasure of moderating the first panel in this series, which featured 4 Indigenous scientists working in the earth and environmental sectors. If you happen to miss that webinar, we will make the content from all of the panels available. I hope that these panels will be an opportunity for all of us to learn and better connect with each other. In that spirit, I will share the website for the GSA as well as my personal email in the chat. Please reach out. And lastly, I'd like to invite all of you to the GSA Connects 2022, which is our annual conference. It'll be hosted in Denver, Colorado from October 9th through 12th later this year. So thank you, Artie, and everyone who's going to be speaking today. I'm really looking forward to learning. Thanks.
Thanks so much, Mark, and thank you, Kelsey, for helping us put together this really important, I think I'm really excited about the series of events that we've been hosting. But without further ado, I'd like to get started with our second discussion today. Today's discussion will focus on land use, climate, and mining for the fossil fuel transition, with a particular focus on how some of the elements and minerals that are necessary for renewable energy are impacting Indigenous peoples and Indigenous lands. I'm going to turn it over now to Kendra Zamzow, who is a member of ESAL's steering committee and also the environmental program manager for the Chicxulub Native Village in Alaska. Kendra is going to tell you a little bit more about this topic and then introduce our amazing panel of speakers for today. So I'm really looking forward to this discussion, and please add questions in the chat, add questions. I think we have the Q&A set up as well. We will have plenty of time for Q&A toward the end, but we'll try to address some questions if possible in the chat throughout the event. So thank you, and I'm going to hand it over to Kendra.
Well, Willie John, my name is Kendra, so good day. I'm calling in from the unceded and traditional lands of the Ahtna Athabascan people, which are part of the Dene group. And I want to, can we go to the next slide? I wanted to try to, one more slide, the prologue. Yeah, I wanted to try to very quickly draw together how these topics are all linked, and then we'll move into the panelists. So the transition that we're all envisioning includes solar panels, wind turbines, electric vehicle, utility scale battery storage, lots of different technologies to move us off of the fossil fuels that we know that we need to do. And all of these technological fixes require some kind of minerals, and many of them are minerals we don't have enough of in our current mines. And they're located in different parts, sometimes different parts of the world, or next to Indigenous lands in this country and in other countries as well. Mining, for as long as the US has been here, mining has frequently been on or near Indigenous lands. In some cases, Indigenous lands had been set aside for Indigenous people, and they were moved because there were ore deposits where those people were told that they could live by the US government in the 1800s. So there's been a very long history of mining in Indigenous lands connected. And this panel will be exploring kind of these different intersections of how do we get off of fossil fuels. Obviously, climate change is impacting everybody, including Indigenous people and their lands. So how do we do that in a way that doesn't actually make the problem worse? And I don't know if we'll come to any conclusions, but we'll certainly explore the issue. So next slide. Our panelists today will start off with Dr. Glenn Miller from the University of Nevada, Reno, which, full disclosure, he was my PhD advisor. And we're bringing him on to talk mostly about lithium, but he has a deep, deep knowledge of mining, both from the anti-mining activist side and from looking at it for the future of the minerals that we need going forward for the transition. And then we'll move to Laura Stoy, and each of these panelists will do a further introduction, a deeper introduction of themselves when we get to their slides. And she's been really looking into how do we use waste like coal ash, a waste material, and extract minerals from that, so we're not disturbing new lands and maybe even cleaning up some lands. And then we'll move to Tommy Rock, who is Navajo and has done a tremendous, has a tremendous CV of work that he's done around uranium and health. And very excited to have him on here. And finally, we'll end with Lori Suter, who's the Mineral Resources Administrator for the Tohono O'odham Nation, which is down in the southern part of the United States. And all of our slides are going to be pretty short. We're trying hard to leave about 45 minutes at the end of this session for plenty of discussion between panelists and the audience. So really excited to see everybody here. And I'm going to kick this off with a couple of slides, again, to kind of introduce you to the topic, just 3 quick slides, and then we'll move on to Dr. Miller. So next slide. So first off, this is just a general, for those of you that aren't familiar with all the kinds of different metals that go into the different technologies that we're looking at, this is just a quick slide of some of the minerals. Some of them are very common: aluminum, iron, molybdenum, copper, zinc, manganese. Those are all pretty common minerals that we mine now, but we have a lot of new ones that we need as well. Next slide. This is a animated series, so if you click, we'll go through. So this is a picture of a hard rock mine. Most of the material that comes out of these kinds of mines is waste material. Just a little bit is economic that we call ore. Next. And one more. There we go. So this is a picture of what a waste rock pile looks like. It's actually almost like a mountain. If you take that mine and you invert it, that's kind of what your waste rock looks like. There really isn't very much ore that comes out of most of the hard rock mines these days. So there's a lot of waste that needs to be dealt with. Next. Of the ore that does go to the mill, again, there's a really large amount of that becomes waste, and this is called tailings material. And this is very finely ground ore, about the consistency of silt, along with all of the process chemicals and water, and they create these huge ponds, and they can be really quite large, like small lakes. So this is just one kind of mining. You can develop, if you see that the mine up in the upper right corner, that could become a pit lake, allowed to fill up with water. That's another kind of potentially contaminated, but not always contaminated feature on the landscape from mining. So all of this is just to give you an idea of some of the landscape scale features, some of which are actually so large you can see them from the moon for the largest mines that we have. And last slide. But of course, there's a reason for all of this, and it's making the quality of life better for all of us. And that includes even here in Alaska, where I am, we are using solar, we are using heat pumps, we are using wind. Villages are creating their own operations and maintenance for wind turbines and creating companies. And so there's a lot of exciting work going on, even up here where you would think a lot of these technologies maybe wouldn't work quite as well. And some of them don't. Electric vehicles don't work all that well up here unless you have a heated garage. So with that, I'd like to go ahead and go to the first panelist. And I think if people can save their questions, toss them in the chat, toss them in the Q&A. And again, we'll try to have at least 45 minutes at the end of this for everybody to have a discussion. And Dr. Miller, you are on.
I was misnamed. My name came up as Kendra's, but I think we figured that out, so we're good now. I'm going to talk a little about sourcing lithium because it's been a controversial issue in Nevada because of some indigenous issues and some other people who have been not supportive of lithium. I personally have, and I should probably admit that up front. I think it's a good project and one that is important for Nevada. But the different sources of lithium, all of them, just like any other kind of mining, there are always issues associated with different impacts. Next slide. There's primarily three types of lithium deposits. The ones that Australia has most of, they produce about half the world production, at least in 2020. These pegmatite, spodumene hard rock ores in Australia. I just might mention, I was just reading recently that Albemarle and Piedmont both are looking at the same type of rock in North Carolina. Saline brines, that's a major source of those is probably from the lithium triangle of Argentina, Bolivia, and Chile. But also there's a brine deposit in the Salton Sea in California. I'll mention that a little bit later. And then the clay deposits from calderas, many of which in Nevada, and some of the most active exploration is now in some of these lithium deposits that exist in clays, and all have different issues associated with them. Next slide. These pegmatites, these generally contain the highest content of lithium ores, up to, I've seen as high as 2.5%, although most of them are around 1%. They're expensive to process, and so there's always going to be a conflict about whether they're going to be commercial, because these require milling, blasting, milling, which is grinding to a small particle size, followed by probably transport to China. At least in Australia, that's the case. And then they have to heat it to approximately 800 degrees centigrade. It's called calcining, and then followed by an acid or base extraction. So it's a lot more energy requiring, and I think the carbon footprint is going to be quite a bit higher for these particular sources. They're found lots of places in the world. There's very large deposits in Africa that have been located and people are developing. Both North Carolina and Maine have deposits, but they're common throughout the world, and this is not an element that had a whole lot of use prior to the battery need, and now they're becoming very important. The physical impacts are similar to other hard rock mining methods. Next slide. Next slide. Oh, is there a slide before this? I'm sorry. I must have gotten taken out somehow. Go ahead. Go. Saline brines are found in many areas of the world, but extensively in the lithium triangle of Argentina, Chile, and Bolivia. The issue with these brines is they occur in very, very low water areas. And what they do is they pump the water from the groundwater system, which is a very salty water, and bring that to the surface and allow the water to evaporate to solar concentration of the lithium and the other salts. The issue with this is it begins, once you create a zone of depression in an aquifer, it starts to draw in other water from other areas. And this is one of the biggest issues, and where a lot of the indigenous communities are particularly concerned about the water consumption from those brines, because it's allowed to evaporate. It brings in good water from outlying areas in some cases. But this is still a very large resource, and it's being developed by several companies, particularly in Chile and Argentina. The Bolivian saline deposits have a fair amount of magnesium, which makes it competitively a little bit tougher to isolate the lithium carbonate. The other one is the Salton Sea geothermal brines in Southern California. It's a very, very large source, and people always look to this and say this would perhaps solve a majority of the lithium issues if there was a way to extract out the lithium that was cost effective. But there's some real question of whether this direct lithium extraction process is scalable, and it's not been proven that commercially viable as of yet. But a lot of smart chemists are working on this, and so these different sources, all this is going to depend on what the price is and what the demand is going to be. Next slide. This is the Silver Peak lithium mine. It's the only operating lithium mine presently in the U.S. It's probably central, western central Nevada, and it's been operating for 30 or 40 years. And this, you can see these brine evaporation ponds in the center. And this is pretty much the same kind of saline brines that are Argentina. This one is very small. It's about 4,000 tons of lithium carbonate equivalent. And the clay mines that are being proposed will have 40 to 80,000 tons of lithium carbonate equivalent. And so you should hear a lot of numbers thrown around where lithium is going to come from. But I don't think there's any question that Nevada will probably have fairly large lithium resources being produced in the next 5 to 10 years. Next slide. The clay deposits that Nevada has are historic calderas. When the Yellowstone complex of volcanic activity used to be in northeastern Nevada, what is northeastern Nevada now? And these were very large systems that blew, and then the material that was discarded had a fair amount of lithium, and that all came back into those lakes that were created with the calderas, and with high concentrations of lithium, that 0.2 to 0.5%, 0.2 to 0.5% lithium, which is a fairly high concentration. They're easy to extract in that you just take the clays and suspend them in water, neutralize that water, then filter out the precipitate and the clays, and then you have a clean solution of water that is actually neutral by this point. And in that processes go on to the same kind of evaporative concentration and formation of lithium carbonate. Partial refilling of the pit is one of the advantages, I think, of these clay deposits. And so they're different than a hard rock mine is going to be. And by the way they mine, it's more attuned to coal mining, where they strip out different sections, pour in the waste material back into the previous one. There will be a large tailings facility. This is one where it's been controversial because of Indigenous concerned on the impacts of cultural lands. These are issues that are non-trivial, and I don't want to underestimate those, but they are. This is probably the largest clay lithium deposits anywhere, and I've heard it's some suggest that it's the largest and highest concentration of lithium, and they will produce again about 40 to 80,000 tons of lithium carbonate equivalent each year. Next slide. There's just some points to consider on these. The lithium is going to be mined somewhere. It is simply the case that I think people around the world are so concerned about climate change, and lithium is the critical element necessary for transportation batteries. It's lightweight, electrochemical properties are particularly suited for transportation batteries. We don't know which of the sources of lithium are going to dominate, and will depend on the economics and response from communities near this resource. It's also important to mention that battery technology is rapidly changing in the relative importance of a variety of metals, including lithium, also cobalt, nickel, antimony. It's still unclear, although current batteries depend on lithium. There is going to be a major effort to recycle, and that is evolving at the present time. So but there's simply not enough lithium in the market today to cover the needs in the transportation industry, and that's the single largest source of carbon dioxide release in the atmosphere. If we don't do something about the transportation sector, we're going to have a hard time really making any significant progress to solving climate change. And that's all I had to say. Kendra?
Yeah, thanks. Thank you, Glenn. That was a great introduction. Be nice to see what some of these different kinds of mines look like, and because I know they're all very different. So our next speaker is Laura Stoy, and I will let her introduce herself because she's had some really interesting background. And for those of you that aren't following this field very much, she'll be talking about rare earth elements. And interestingly, they actually are not rare, and she'll probably let us know about that. So go ahead, Laura.
Awesome. Thanks so much, Kendra. All right. Hi, everybody. My name is Dr. Laura Stoy, and I'm an expert in resource recovery. I'm really focused on rare earth elements. I recently completed my doctorate in environmental engineering, looking at rare earth element extraction from alternative sources. But before we get into that, what are rare earth elements? So there's 17 of them, as you can see in that in the periodic table, the lanthanides and scandium and yttrium. And they play invaluable roles in a lot of different high-tech applications: permanent magnets, LED screens, fiber optic cables, wind turbines, cancer treatments, almost anything you can think of, and more. As an example, one rare earth you might have heard of is neodymium, used in permanent magnets. An electric car right now requires about 6 pounds of neodymium. The hard drive in your laptop usually requires about 20 grams, or like 20 paper clips, I guess is a way to think about that. Just like with lithium, we don't know the exact future of technology, but what we do know is that right now, rare earths are critical for a lot of these different applications, and there are no substitutes. And while this wouldn't really be a problem, because technically rare is a misnomer, some rare earth elements are just as plentiful in the Earth's crust as common metals like nickel or copper, but rare earths do not occur geologically in exploitable ore deposits generally. You're not going to have a neodymium mine like you have a copper mine or a gold mine. Next slide, please. So where do we get our rare earths from? So the US used to lead the world in global production, but now the United States is a net importer of rare earths. So more than 80% of the world's supply is owned and produced by China. So what this means is that the rare earth element supply chain is very sensitive to disruptions. So if there was something like a trade war between China and the United States, talk about old news, or a ship blocking a major canal, or a global pandemic, there could be pretty significant consequences for manufacturing in the US and around the world. So as a result of this kind of supply chain sensitivity, both the United States and the European Union have classified rare earths as critical materials. So the graphics here kind of show where rare earths are kind of globally and how the United States imports them. Given China's dominance in this field, a lot of other countries have started building up their rare earth element mining capacity. The United States has reopened a mine out in California. And then Australia has also started dramatically expanding into this space. So, but one thing that we can think about, though, is there is a way we can avoid mining. Mining has a lot of different environmental hazards related to it. And you can see in this picture here, this is a picture, I believe from Scientific American, but there are a lot of illegal mines in China also. It's not just these kind of giant mines that we have, that we kind of classically picture when we think of mining. There's also a lot of smaller operations in China that kind of fly under the radar and have their own environmental hazards associated with them. So, to avoid mining, there's been a big push to explore other sources of rare earth elements. So, we can mine them. We could recycle them from some of the end of life products that I mentioned, batteries, computer monitors, permanent magnets. But this has a lot of challenges associated with it, namely that most products aren't designed in a way to make recycling easy. So you have these products that have very low concentrations of rare earth elements, scattered throughout, your cell phone or whatever. And the energy and effort required to extract those rare earth elements back it's just not going to be, it's not a good strategy to get more rare earth elements, right? So the next sources we can look to are low value waste streams, like waste from other mines or coal fly ash. Next slide, please. So what I have looked at too pretty extensively is extracting rare earth elements from coal fly ash. So these are these spherical particles you can see in the inset there. They're about 0.01 to 100 microns produced from burning coal for power. We produce about 130 million tons generated, or we produce about 130 million tons every year. About 60% of that can be beneficially reused and in concrete and wallboard. Most of those applications are actually very safe because it's a chemical transformation process that kind of locks anything that might leach out of the coal ash, into that new concrete structure. But the remaining, 50 million tons is landfilled or stored in ponds. And it's estimated that there's more than 1,400 storage ponds in 45 states and on top of that, and that's just, so we have these 1,400 storage ponds, we've been burning coal for decades, right? So we have over 1 billion tons of ash and ponds. And this represents about 100 years of our current demand for rare earth elements. Now, coal ash tends to be pretty variable in its morphology and mineralogy and composition. It depends on the parent coal, so the ash can be different, but we always see that, or we pretty consistently see that rare earth elements are enriched in coal, in this coal ash. So, the coal is kind of like soil in that it's not particularly enriched. But when we burn coal for power, that resulting combustion product is enriched in rare earth elements. Most importantly here, though, is that there's no mining required. We have this ash sitting above ground in these, giant ash ponds, essentially just waiting for us to take the next step to recover the rare earths. Next slide, please. And there's also the problem of the coal ash itself. So the image here is from the Kingston ash slide in Tennessee that happened a couple days before Christmas in 2008. 1.1 billion gallons of coal fly ash spilled from a pond. The retaining wall had not been properly reinforced, and spilled. It flooded the neighboring body of water, buried houses. These spills, we have these catastrophic spills like you can see in this picture, but we also see groundwater contamination. You have to have water nearby for coal combustion for cooling tanks. So a lot of them are located near rivers or lakes. So groundwater contamination is really common, in part because the ash retaining ponds are often unlined. And these ponds are at risk from extreme weather events, from climate change. So the coal ash problem is, something else that we are going to be dealing with as we see continuing impacts of climate change. So treating this waste, treating coal fly ash as a resource can actually decrease storage hazards and decrease mining operations. And while I focused on coal ash, another source of rare earth elements is abandoned mine drainage sludges. So, if you think of the classical picture of, the bright orange sediments coming out of abandoned mines, a lot of those tend to be enriched in rare earth elements also. And, in my mind, this rare earth element recovery goal here strikes at two problems. We need rare earth elements to power our green energy transition. And we have the second problem. We have these big messes, these ash ponds and these abandoned mines that are hazardous to local communities. And I'm really intrigued by the idea of tying these problems together. Can we clean up these sites with the goal of recovering rare earths and other valuable minerals? Can we, I think the term is feeding two birds with one scone, right? Is there an opportunity here for dual benefits that really can benefit the local communities? And that's all I have for now. I'm looking forward to the rest of this discussion.
Great, thank you very much, Laura. Our next panelist will be Dr. Tommy Rock, who is Navajo and has been studying uranium and health and a variety of issues around that for quite some time. And I will let him do the full introduction. Thank you, Dr. Rock.
Hey, let me introduce myself in Navajo. Tommy Rock Conchero, Odet Turinasha, Arashidone, no dashing slant, somebody seen Turicini, there's a chedo, look at Nate National, Hi, this, that was a formal introduction in my language for my Indigenous people out there that are listening in. That's pretty awesome. Thank you for listening. Yeah, that's my hometown, Monument Valley. Next slide, please. Just a little background about me. It's like I was raised by my grandparents. That's my grandmother, and the person on the right is my grandfather. He was a World War II vet and a former uranium miner. And the picture on the right-hand side in the corner, that was the last uranium mine that he worked at. He saw one of his colleagues that got crushed to death, and that was the last time he worked in a uranium mine. And what's going on now is you see a lot of the abandoned uranium mines and effort to do remediation on their sites. Not only abandoned uranium mine, but we do have some uranium mill sites on Navajo as well. And there's, I believe, 24, I think, across the US and the West particularly. And the left-hand corner map, that just shows you different pathway of exposures. That is Navajo Nation. It covers 3 states, Utah, Arizona, and New Mexico. And the triangle, little black triangle, are the abandoned uranium mines. There's 524 abandoned uranium mines on Navajo Nation. And the color represents like how people are being exposed, like water contamination, people going to these former mine sites or mill sites, getting materials and taking them back home to build homes, foundations, sheep or horse corral or what have you. So those, the darker they are, there's multiples pathway exposure, and the lighter ones are where there's no abandoned uranium mines or mills. And that's what that map shows. And on the 4 maps that you see there, they are maps of where their mines are located. The first mine is at Bears Ears, and then the second one is in a place called Caney Valley, and two mines are in Monument Valley area, Skyline Mine, and my hometown, Monument Valley, which is on the last map that you see there. So I grew up in Monument Valley, so it was, when I was growing up, was able to explore a lot of these abandoned uranium mines, explore them with my friends. So now there's still quite a bit of that around. Next slide, please. And this slide just shows you the mineral extractions, hard rock mining that's going on in the Western US, and shows you the proximity of tribes that live near these abandoned uranium mines. So there's about 15,000 abandoned uranium mines in 14 Western states. And it's not only affecting my tribe in the Four Corners regionally, but it's affecting other tribes as well, like that live in the Four Corners, the Hopis, the Pueblo tribes in New Mexico, the Havasupai, the Ute tribe, White Mountain Ute. The White Mountain Ute, they have the only uranium mill near their reservation, so they're trying to fight that. And so when you look at the full picture of uranium mining, you see the beginning and the end, and regardless of which and you're dealing with from the beginning or end, there's like an issue with uranium exposure or the radioactivity related to uranium mining. Next slide. And this slide shows you where the energy is going. It's like there's talk about nuclear reactors. They're smaller and can be transported in other places, like in isolated areas. And yeah, it's like still uranium mining though. So regardless of this mini or micro nuclear reactors, like the issue has always comes back to what you're going to do with the waste, where the waste is going to be disposed of, or where it's going to go. And another is thorium reactors, like where the energy is going, or where there's different countries that are doing research on thorium. And so this seems to be like one of the answers, one of the solutions of providing energy to the majority of the population, not only in the US, but other countries as well. So this slide just shows you where the energy research and where research is going in, and how this new energy is going to be, where the energy is going to come from, basically. And this is like besides renewable energies, by the way. Next slide. And this slide just shows you some of the health issue or uranium exposure in indigenous community, and some of the abandoned mines or that are still out there, stuff related to water contaminations. There's signs up there, since the nation doesn't have the full running water, so there's an issue with the lack of potable water on our nation, water infrastructure, basically. So people go to a lot of these isolated, unregulated waters, wells, springs, or what have you, and get water there. Some of these wells are contaminated by uranium, so you see a lot of signs or plaque, such as this picture on the right hand corner. And then there's other places off the reservation that still have abandoned uranium mines that are still open, and some of the ores are out in the open as well. So it's still an ongoing issue, and there's still a lot of work that needs to be done in terms of the public being exposed. And I think that's the end of my slides, I believe. Thank you.
Great, thank you very much, Tommy. Yeah, so I hope people are getting some sense of both the possibilities and the health issues inherent in a lot of these different types of minerals that we'll be needing. And the last panelist that we have for today is Lori Suter with the Tohono O'odham Nation. And we'll be talking more about both the impacts and the opportunities. So, Lori, are you ready to go?
I'm ready.
All right, thank you.
So the image on this slide is the sacred Tohono O'odham Babakiri Peak that involves the origin stories of the O'odham people that go back at least 10,000 years. In the O'odham language, Himdak embodies the O'odham pathway to wellness, healing, and balance, and it incorporates all the cultural practices, the language, the games that people play, the arts, the kinships, the desert environment itself, and desert lifeways, all of which are part of the O'odham balanced, holistic, lifelong journey. Hi, by the way, I'm Lori Suter, and I'm the Mineral Resources Administrator for the Tohono O'odham Nation's Natural Resources Department. I cannot now, nor can I ever, speak directly for the Tohono O'odham Nation. What I am is a representative. And I'm a geoscientist that provides the nation with the decision makers, the legislative council, the executive office, with scientifically sound information concerning mining technology, and potential impacts one way or the other. I have extensive background in this particular industry of extraction, as well as environmental education and etc. I'm very honored to be included in this panel, and I do really thank everyone who's also attending, because this is a really important topic now and into the future. Next slide, please. So in the United States, over a century of hard rock mining has left thousands of abandoned mines in nearly every state of the United States. And I just really don't think your general population of the United States ever really has a indication of how impacted the United States actually is from the past. And I think these maps graphically display the USGS data in relation to tribal lands. The vast majority of these abandoned mines affect Native Americans as well as their sustenance lifeways, their tribal rights, and the land itself, land, water, air, all of it. Widespread access for mining in the United States began with the gold fever in the 1800s, and by 1872, a mining law was enacted, which is still the law of the land today, with a few additional changes here and there. But by the 1970s, some of the uranium-rich areas of the United States were actually designated as potentially uninhabitable sacrifice zones, even though tribal people still lived on the lands. And that's shown very well in Tommy's slide, where it showed the Utah, Colorado, Arizona, and New Mexico impacts. And this was an area that was designated as an uninhabitable sacrifice zone. The other thing I wanted to show is the Tohono O'odham Nation itself, since that's who I work for. And it's a federally recognized sovereign nation covering 3 million acres, which is about the size of Connecticut. And we share 65 miles approximately of the international border with Mexico. And the land supports about 35,000 enrolled tribal members. The Sonoran Desert ecosystem, where the nation is located, only gets about 8 to maybe 11 inches of rain in a really good year, mostly through we get spring rains, and right now we're in our monsoon area. So we'll get most of our rain right now. And yes, we're in a drought for years on end and have to mitigate that for many reasons. The autumn legacy of mining began with Spanish colonizers, the conquistadors, actually in the 1500s. And yet it wasn't until 1959 when the Tohono O'odham Nation had received any money in exchange for the minerals extracted within the boundaries of the nation. Today, we have two active copper mines. One is a Superfund site because it has impacted the groundwater, and one of the chemicals of concern is uranium. Also sulfur and perchlorate, excuse me. We also have about 80 patented and unpatented private claims where they're privately owned, and so therefore the Tohono O'odham Nation does not receive any kind of royalties or I think we get $5 per acre or some very horribly low amount of funding for any activities on those claims. And they predate 1955 when the Surface Mining Act changed some of the laws. But we also have hundreds of legacy abandoned mines, which are shown in this pockmarked US Geological Survey oriented map, and going through and finding them, and I have 80 of these sites are within a mile of a village. Next slide, please. So according to the 2015 census, I mean, that's a few years back. I don't have more recent information, but at that point in time, there were approximately 7 million folks who declared themselves as Native Americans. And of those, over 600,000 were located within 6 miles of an abandoned mine. Due to greater susceptibility and greater exposure factors, Native Americans are at a greater risk than the general population of adverse health effects from exposures to chemicals in the environment. Tribal communities have ties to the environment that are much more complex and intense than is generally understood by the risk assessors. Now, risk assessments are designed to calculate health hazards posed by contamination, but they don't adequately address exposures unique to Indigenous societies, especially since they often use default values. So, you know, this is a slide that shows that there are impacts from mining itself, which, you know, your general population individual can move away from. But if it's on tribal lands, it is a lifetime of exposure. And then there's also, you know, eating off the land and all of the activities associated with being a tribal nation are just different from what you would find in, say, Washington, D.C. or Chicago or other areas of the United States. Next, please. So traditional ecological knowledge is the knowledge of relationships between plants, animals, natural phenomena, landscapes, the timing of events that are used for lifeways, hunting, fishing, trapping, agriculture, forestry, and etc. So let's think for a minute in terms of a Native American thought process, and that includes the next 7 generations. Now, 7 generations is about 150 years. So in the thought processes of a Native American population, it's like, what will this land look like in 150 years? Will it be barren or will it be thriving because we've managed our land well? Mining companies need to honor this traditional ecological knowledge, and the inclusion of Indigenous science and traditional knowledge can help develop sustainable land management practices. There are ways to build relationships that create win-win situations, and all of these, you know, the Native nations need to allow for traditional knowledge surveys. They need to make sure that the people are educated and trained, as well as coming up with some of their own standards and regulations. Early and frequent consultations are really important with the federal agencies involved, but participation in public meetings and tours of these sites are really important for disrupting, you know, the fact that Native Americans are generally not brought to the table. With doing that, positive outcomes can take place. The minerals can be extracted, as well as providing for economic development and infrastructure development in the tribal lands, community development, scholarships from the mining companies themselves, as well as lots of employment opportunities. And then on top of that, anybody who's employed by a mine does spend their money locally, and that also benefits the economy of tribal nations as well as everyone else. Next slide, please. So let's keep in mind that we humans did not place minerals where they are located in the environment. And of the untapped critical minerals in the United States, 97% of the nickel, 89% of copper, 79% of lithium, and 68% of cobalt, all of which are considered key for energy transition, are within 35 miles of a Native American reservation. So, let's work on finding some middle ground and figure out ways to work together to make this trillion-plus industry, the clean industry boom, a win-win for all the people and our planet. We all enjoy the benefits of modern technology. I mean, we couldn't be doing what we're doing right now if it wasn't for modern technology and computers and phones and cars and et cetera, et cetera. However, the benefits and the profits towards these green energy developments should not mean more than Native American or Indigenous people's survival any place in the world. Thank you. That's what I have to say.
Great, thank you. Thank you to all of our panelists. Again, feel free to put your questions in the chat or in the Q&A. But I'd like to go ahead and start this off. And this is for any of the panelists. Feel free to engage in conversation between yourselves and turn your cameras on. I guess I was struck when Dr. Miller said there's one current lithium mine in Nevada, and when Dr. Stoy said there is one existing REE mine in California. And we know that a lot more mining is going to be required. And I'm thinking, okay, so we have tribal governments, which are sovereign governments, and many of them, if you're outside of Alaska, they have their own, not all of them, most of them have their own reservation lands, which would have, you would think it would have your own control over what happens within those borders. And so I'm curious if you could talk a little bit, we don't have time for an entire Indian law session, but if we talk a little bit about how does permitting for these new mines that are going to be happening occur within lands that are part of a sovereign government? And how do you do that interaction between the mining companies, the different governments that might be involved? How do you have any say over what's happening on those lands? Sure, Lori.
Well, it is pretty difficult. As a sovereign nation, the Tohono O'odham have provided for laws, for instance. Now, we don't have our own standards for cleanup, but we utilize state or federal, whichever is higher. But on the other hand, there was an incident within the boundaries of the nation where approval was asked to do just a gravel pit, but it was going to impact over 300 of our cactus, of the giant cactus. And as a result of that, actually, the Tohono O'odham Nation declared that these were sacred objects, that they need to be considered under resolution as you would a human, because they're considered ancestry. So the point is, by being a federally recognized tribe, there is the option to create your own standards, and then people have to listen to that, as well as federal and standard rules and regulations, as well as consultation. Now, the problem comes in when it's not on the tribal lands themselves, and then it ends up being, you better have some really good lawyers who can go out there and put your point of view into the particular situation. And there again, we have an off mine, or a mine that's off the tribal lands. You know, it's impacting traditional lands, but the issue is that there are hundreds of burial sites in this area where they want to do a huge giant copper mine, as well as endangered species. So, you know, that mine itself has been protested. Now, the mining company kind of went around the block and bought up a whole bunch of private lands. And then the problem with private lands is you don't have to meet NEPA. So there again, if mining companies really want to mine, which, you know, that's where the minerals are, they need to start consultation very early and talk to the people and find out why they have objections and see what can be mitigated in order to, you know, prevent some of those negative outcomes.
Yeah, does anyone else want to contribute to that answer?
I was going to say, I think this is kind of my push, you know, to avoid mining, you know, to go to those sources that don't require, you know, infringing on lands that should have another purpose. You know, they are these, you know, sacred sovereign lands. They already are doing a job, right? They already have a role that they are playing. But to the end that we need, you know, lithium to power, you know, like our green energy transition, right? Like I think taking mining off the table entirely is probably not a workable solution, right? So my expertise is really kind of in the alternative sourcing, but it definitely seems like there should be some kind of consortium that provides a space for you know, sovereign nations to meet with mining companies and like make sure that all of the needs are on the table. That might exist already. So it's probably not a new idea.
I don't think that does exist.
You're shaking your head. Why doesn't it exist? That feels like it should exist.
Can you repeat the question again, please?
Yeah. Well, I was struck by the fact there's only one lithium mine and one rare earth element mine in the U.S. right now, and so all of these new ones that we need, they all require permitting. And I was curious about the interaction of companies that want to get something permitted. When you're in a sovereign nation, you have your own rules and laws. And so how do you interact with the companies and with the governments around that? And Lori was talking about how a lot of that is really more about what's on the edges of the reservations than what's within your actual territory where you can set the laws.
Mm-hmm.
Well, from a lot of the work that I've done, like researching, a lot of it related to uranium mining, and all, it's like, and mining in particular, is like, there seems to be no company that's like held responsible for a lot of the cleanup that needs to happen, especially if you look at the presentation that we've done. There are still quite a bit of hard rock mining that needs to be remediated and addressed, and it's not happening. So in terms of tribes and mining, it's like, I think the discussion should be more about cleaning up these past mining activity before we can move forward and start talking about some more mining that's going to happen.
Yeah, that was something else that struck me. Was you said there's over 500 abandoned uranium mines, but only 4 of those are Superfund sites in the Navajo area.
No, it's like there's two separate things that's going on there. Is like the four sites are former uranium mill sites. Those are the Superfund sites that was addressed, and there's that policy related to that. It's like the Uranium Mill Tailing Radiation Exposure Act, UMTRCA. And when it comes to uranium mining, there's no such policy to address a lot of these uranium mining. There's like about 15,000 abandoned uranium mines across the U.S. and there's no discussion about that. I know of, not only my tribe, but there's other tribal nations that talk about addressing those abandoned uranium mines as well, and it's still an issue. It's like it's not only an issue of contamination, but it's also a public health issue. It's like we don't have a really good healthcare system in the U.S. So I think it's like a discussion should be like leading that way. Is like how we're going to solve this issue about these abandoned uranium mines. Maybe not just abandoned uranium mines, but the hard rock mining that has happened in the past, and also making some changing with the mining law. Was it 1872 mining law? I think is it 1872 or 1874?
Yes.
Yeah, that mining law needs to be changed as well.
Mhm.
Yeah, so I guess I am curious about a couple of different intersections, and some is coming from the chat here. But one, Laura talked about mining coal ash, and of course, there's been big coal utility plants in the Southwest, including on the Navajo Nation. And is anyone looking at that as an opportunity to clean up some of that waste? And of course, with copper mines, there's a lot of waste, and there can be acid mine drainage, again, possibly an opportunity. So I'm wondering if you could talk about some of that, these waste materials on Indigenous lands, but also are there examples of successfully remediated mines, copper or uranium? Let's focus on maybe those two to start with.
The only ones that I really know of are coal mines, where they, the Surface Act, which was the 1955 change in the law, kind of separated hard rock mining from coal mines, and nations that have coal mines on them actually do get some funding, quite a bit of funding actually, to remediate those. As far as actually hard rock mining though, even right now in the bipartisan law, they were talking about putting in a couple $2 billion, or even a few million would be nice, towards cleanup of hard rock mines, and it's just not there. So right now we have Superfunds, which are, you know, the most polluted sites. I think there's about 150 of those that are hard rock mines, and I don't know how many of those might be uranium. But, you know, and so those are getting somewhat addressed, but it's all these little guys that are, you know, 40 acres here or there, and weren't really ever productive in the first place, that, you know, they left holes in the ground. You know, some of them are 500 feet deep, and they do necessarily impact water, air, etc., especially when they're within a mile of a village. So, you know, that's one of those things where I really advocate that the federal government needs to get their act together and provide some funding associated directly with reclamation of hard rock mines. And as far as utilizing, you know, there are ways where some of the old waste rock piles could potentially be turned into productive ore, because at the time that they were made, the ore level may have been 1% in order for it to have been a good mine, where now we're down to about a 0.25% of that same, you know, element, whatever it might be, whether it's copper or uranium. Uranium has left behind huge waste rock piles, and some of the things that I read about that say that there's still a huge amount of radioactivity associated with them. So there again, new technologies would be great. Laura, the fact that you're coming up with some new technologies is fabulous. I've heard of a couple other ones, but there again, the new technologies have to take into consideration, we don't want something to be a fix that ends up being worse than what we had before. And, I can say that about fracking for oil and gas and some other kinds of things that we've done as a country that are not necessarily in the best interest of anyone, let alone tribal people.
And I think part of this discussion also goes to economics. We've been talking about how some of this mining waste may not be economic right now, but there's a question that came in the chat that said, well, you're not considering all the externalities. You're not considering the health issues. You're not considering all the burdens that are being placed on people. So I wondered if you have some thoughts on that. And yeah, Lori, for people that don't realize it, coal mines have to pay into a fund for remediation. Hard rock mines do not. So that's
Right.
part of that division that people may not be aware of.
Well, I also want to point out that there are a couple of acts that have been bouncing around Congress for updating that law. And one of them I read put tribal lands back into where they had to ask permission from the federal government not to allow for mining on them. And, it's just like, okay, let's go back to the 1800s. And so, luckily, I get asked about some of those kind of things and I read them and I understand it. I had to read that act like 3 or 4 times before I went, yeah, that really is what it says. So, it's just because we need to have that updated, and both of the ones that I saw involve having hard rock mines pay into a similar fund for remediation. And, so hopefully we'll get some progress along those lines. But meanwhile, we do have the brownfields program that's quite well funded, and you have to have a really good brownfields program to work through that, however, because they have a lot of other issues besides abandoned mine lands to deal with.
Yeah, and for people that don't know what brownfields are, those are potentially contaminated lands that are not being used to their highest and best use. And so new development can be on those, and it may or may not include remediation, may or may not be a contaminated site. Yeah. Shoot, now I've lost my train of thought.
Sorry, didn't mean to retrain you.
Here we go. I guess it was again from a question in the chat. It's these ideas of funding the remediation. So if companies do want to come into areas where you have sovereign government control, are you able to put those kind of conditions on the mining, that you have to have a certain amount contributed into remediation? Do you get to say when it's remediated? Do you get to put in special air and water standards around that mine, or have them address some of the past health impacts before they can mine? Is that anything that's been done?
I don't know that it's ever been done, but yes, the tribal nations have the right to create their own standards and then hold anybody who wants to come on their land, other than the pre-existing patented and unpatented sites. But we do that with the mines that are on tribal lands for the Tohono Nation, both of which are copper mines. And so, did I raise my hand? Oh no, I don't know what that is. Anyway, so yes, and we are holding, Freeport-McMoran to higher standards for proving that what's there is not going to contaminate. Show us how you're going to deal with it. And over the years, they've done a really good job with remediation to above and beyond the standards that are necessarily set by the federal government for the nation. You know, if a mining company wants the minerals, then yeah, they need to jump through some hoops.
I wonder if there's an opportunity here for building up kind of a public interest in ethical sourcing of minerals. Like I'm thinking of now, like, you know, you can buy fair trade coffee, or you can buy, you know, Rainforest Alliance coffee and products, right? That's like, we certified that this product comes from this place. And, you know, it's hard to do that with minerals because, you know, of all of the 17 rare earth elements, all of them are in your cell phone, right? You can't see them, they're invisible, right? So I wonder if there's an opportunity for some sort of like licensure program, whether that's like a government or a private kind of initiative that would provide the American people, like provide people who, you know, buy stuff, you know, consumers, with a way to purchase things more ethically, you know, buy, like, I want my, you know, I'm finally going to pull the trigger and buy an electronic vehicle. I want to know that the lithium comes from XYZ, you know, native land, and that the people who live there, you know, were fairly compensated and that the land was taken care of. Like, I wonder if there's an opportunity for that kind of program. I don't know of anything that exists like that right now, with kind of supply chain tracking. I think it would be very challenging to develop something like that, just because, you know, the pieces that we're talking about are so small. You know, the concentrations of and levels of things are so small for a lot of these devices that we're thinking about. And I guess maybe people don't run into a wind turbine every day. You know, at least where I am in New York City, don't see a lot of wind turbines in my neighborhood. So I wonder how we could make that more visible, if that would be a valuable initiative. And
yeah,
that might
that ties into a couple of questions that are coming in. And one is, there actually have been a couple of different global efforts at certifying mines or minerals or companies. And one that was mentioned in the chat is the Initiative for Responsible Mining Assurance, which is, that was kind of homegrown in the US. But it's a voluntary, companies go in voluntarily. It's still kind of just getting started, but it is possibly a start. And there is another question around this. So part of what we would do is what can people do? You know, we see some of these problems, and a lot of them are happening on the edges of sovereign governments where you don't have control, but maybe other people in the US or other countries could be allies in helping to push forward a better way forward. So one of the questions that came in is again on economics. How can you talk about investment and retirement, how this contributes to the cycle, these kind of funds, and how people can make ethical decisions around this? Because it often perpetuates extractive economies, which is exactly why I have had problems investing the little bit of money I have as well. And again, maybe this goes to developing some kind of Indigenous certification or something. I'm not sure.
Ethically sourced.
And then how do you fund that? And does that include taking care of these past issues? You know, companies will come in and say, well, I didn't do that. Well, yeah, but some of these mines, it may look like remediation is working, but, you know, it may take 70, 80, 100 years before you actually see if remediation has worked, because it can take that long for the geology and the water to create the problems sometimes.
Especially nowadays, like I'm looking at the Southwest in particular. The West is like, we don't have a lot of water. It's like we're in a severe drought. Lake Powell is going down, and the reservoirs are going down that provide water for 7 states. And the Colorado Compact need to be addressed as well. And then in terms of solution or looking for energy sources, is like it's something that we have to go grapple with as well. As I was looking at different energy source, that the micro reactors, there's still an issue with the nuclear waste, and then there's thorium, which is it seems a little better than uranium, but it also depends on where these thoriums are located. It's like there's a lot more of that, but it's been on my mind quite a bit, especially with the research and what I've seen doing research related to uranium exposure. So,
Tommy, weren't we talking about the half-life of thorium versus uranium last week?
Yeah.
Isn't it? It's like still a long time, even if it's better. Can you remind us what the half-lives are for those?
Uranium's like 1,000 of years, and then I believe thorium's like 300 years, I think it was.
300. So, you know,
14 generations. 14 generations. So we're getting close to the end, and I would love to keep this conversation going, because there's so much more that I want to ask and other people have asked. But I guess I want to end with just a couple, or ask you to address a couple of other things. One is, we've really focused on technology, but there are a lot of nature-based solutions that are not tech. And even for energy storage, there's this idea of pumping water up to a lake with windmills or diesel generators or whatever, and having it flow back down, storing the energy, a pumped hydro system, which is used in Norway. And there are other, of course, maintaining peatlands and swamplands and things like that. So I wondered partly I wonder if you have thoughts on whether we're focused too much on tech, and if we are, how we can move away from that. But the other thing I'm wondering is how we can bring more Indigenous scientists to these topics, so that we're all better informed from those perspectives. And what's holding that back, or is it being held back? Are we just not paying attention?
I think having these discussions, like in ACES conferences or other conferences that a lot of tribes goes to, and I think having these dialogues and it's like starting a dialogue and having these discussions, I think will really help in terms of getting more students involved and getting more tribes involved and being more informed, I think.
We meaning the Tohono O'odham Nation, one of the really wonderful things that the Freeport-McMoran Company did was provide for a traditional survey. And so it allowed for the people of the community that was most impacted to come in and tell stories of what they remember before mining. Unfortunately, they didn't do this before the mine was already there, but they did do that pre-expansion activities. And so, I mean, we learned things like, oh, did you know there used to be a clay area over here? And this is where we gathered traditional autumn fruits and vegetables, and, you know, some of those kind of things that came out through the surveys. So, you know, that I think is as much on the mining companies who want to come in and get these minerals. You know, if you really want the minerals, you really need to deal with the people who are involved in it. You know, there again, as far as those areas that are off the nations, that becomes a whole nother issue altogether. And I really don't have a good solution other than, you know, things like Earth First and you know, protesting through legal sources.
I was going to say, I think it'd be really interesting, you know, for Native people who live on or near reservations, if there can be, you know, when there are, you know, firms that come out to do testing or surveying, you know, can like some high school kids go along to observe, you know, and like see how measurements are taken. I feel like, you know, not that high school kids should go to field camp, you know, and like learn how to be geologists for a week, but you know,
Yes,
I think they should. I mean, I think that sounds like a very, you know, immersive way to be acquainted. I mean, I guess that's sort of a step towards like the more like using scientific tools to understand a landscape rather than, you know, native understanding perhaps. So I wonder if that could be an opportunity for some kind of program that seeks to blend those together, like a program to like specifically to get kids and youth interested. Do we need
So,
to take?
It's kind of like flipping the script where
yeah.
but it's difficult because there are also private things that Indigenous people want to hold private. But this idea that the landscape is sacred, and how do you approach that as a scientist from that perspective, I think would be a great way to train kids and scientists.
So that's where I wanted to ask Tommy. You know, you're actually an Indigenous member of a tribal nation, and somehow here you are, well educated, providing information back not only to your people, but you know, to the greater good of all. So how did you get there?
For me, it was a personal journey. It's like it had to deal with my grandfather dying of cancer since he was a former uranium miner. So my journey led me to where I'm at right now, and realizing that it's just not an issue not only with my family or my community or my tribe, but it's there's a lot of tribal members that have been affected by uranium and uranium exposure as well. So it's like I do get asked to do a presentation for university through Zoom or what have you. So I'm happy to do that. I think having some of that information on a website, I think is great as well. Having that easy access. So I think Laura's idea and putting some of the ideas on a website, so other Indigenous community members or educators can get access to it and modify those information to their own tribal and tribal teaching as well. I think will be great.
Like some sort of like group sourced curriculum almost.
Yeah.
That could be very interesting. So many ideas.
Yeah.
There are great ideas, and I hope the audience feels free to stay in touch with the panelists with your questions. And speaking of media, High Country News, if you don't subscribe to that, often does have a lot of good stories that touch on these types of issues. And I'm sure our panelists can give you more. I'm not advertising for High Country News, just one source that came to mind. But I really thank all of the panelists for being here. I'm so thankful for the people that contributed to the chat and attended this webinar. And I do encourage everyone to think about how can we further this conversation through creating some kind of a consortium or reaching out and learning how to respect the land and move forward that way. And please do stay in contact with the panelists if you're interested in these. Ahona. Arthi, did you have anything you wanted to say to end, or are you just ready to go?
I think I will also get back on camera, but no, I just want to say thank you to everyone for joining today's discussion. I know there was some discussion of questions about the video. The video of this event will be made available on our YouTube sites, and we'll also email all of the registrants for today's discussion when it is available, as well as any other follow-up materials. And one final note is that the third event in this series of discussion is being planned for late July. So stay tuned. We will contact you when we have final date and time for that discussion, which will really center around questions of Indigenous peoples and their dependence on extractive industries and some of the economic factors that that impact Indigenous communities as they make decisions around extractive industries and land use. Thank you so much, everyone.